just to quickly introduce myself, I'm part of the corporate development and global partnerships team at Ansys, and happy to to provide you more info about how we work together with HPE and AMD and accelerate actually innovation at our accounts. And before going through the slides, I will turn off due to bandwidth. I'm here based in the Netherlands, my camera, but I hope you can still get it very well. So let me begin to say that and Ron and also Mike alluded to that already, that we are living in a fast-pacing world. The world is changing so quickly. The future is also very demanding. The workloads are more and more demanding, and we all know that companies need to innovate faster to basically keep pace with an ever-evolving market, so to say. And at Ansys, we really believe that we are driving innovation and changing basically the world by helping companies develop and deliver transformational products. We do that through engineering simulation, through the power of engineering simulation. With our software, companies can engineer products and processes completely in a computer, without the need to do really cost or really expensive physical prototyping. And that helps obviously organizations really increase their the top line while also driving bottom line savings. And that's really what Ansys is all about. And we have a long history, as you can see here on the screen. For 50 years, companies around the world and across industries, I must also say, have used Ansys to create basically their future. And our customers are solving also next generation product challenges, like electrification, autonomy, 5G, and more. And a few of those examples are shown on this slide. With all permissions, Volkswagen uses Ansys to develop its all-electric race car, which really smashed records at racetracks around the world. Then Airbus, Airbus is employing our simulation to unlock really the possibilities of autonomous aviation. You can hardly imagine, but really autonomous aviation, and keeping the skies in that sense also even, or making the skies even safer, I would say. Consumer electronics powerhouse Samsung is using simulation to solve really what I always call the unsolvable problems, and connect people with the power of 5G. And then we have an example on the right, Medtronic leverages Ansys to develop medical devices that are saving lives today. So customers are using Ansys simulation software to solve really their toughest product or process related questions and business challenges too. With simulation, they can accelerate their business processes, and make products and bring products faster to the market. It also inspires them to innovate, to come up with cutting edge and high quality products, and also it helps them to unlock really their potential by productivity gains, while also driving cost out of their whole processes. But there are challenges. And I started off by saying that already, that the future is demanding. There are always new challenges coming. The market expects cleaner products that are also quieter, safer, faster, more efficient, more reliable also. Yeah, and these are really requirements, or these type of requirements often conflict with each other. Yeah? To make safer, faster, more efficient, more reliable products, those requirements can definitely conflict. Yeah? So achieving really the best solution for all these, let's say, these goals, yeah, requires that engineers understand product performance in greater detail than ever before. Yeah? So they really have to tackle larger industrial problems with more detailed physics. Yeah? Especially, and Mike was alluding to that already, especially in the aerospace and automotive industry, but also more and more in consumer goods market and electronics, high-tech industry. Product simulation models are becoming larger and more complex. Yeah? And the complex, yeah, and the details of it often lie in the phenomena that are small in scale and transient in nature, yeah? Like acoustics or like combustion phenomena, yeah? Which really increase the need for transient simulations with many more time steps, so to say, to solve those simulations. And all these additional time steps can increase the number of calculations needed by orders of magnitudes over the current mainstream simulations. So that these are big challenges. And in order to meet those challenges, HPC is without doubt a must for engineering simulation, a must. And although there are many ways to articulate the value of HPC for engineering simulation, I usually refer to these two boxes that I'm showing here on the screen. On the left, you can see that HPC enables customers to do more design variations. Basically, because of faster turnaround times, they can simulate more designs and optimize more designs. And in this way, they can also become more productive. And they can increase the engineering productivity, so to say. And on the right, I'm showing that HPC also enables customers to run bigger, more complex, more detailed, more accurate, more complete models. And altogether, this will yield better and faster innovation, faster time to market, and less rework. Less product withdrawals, for example, from the market through HPC-enabled engineering simulations. So, and although I realize that this is a bit of a busy slide, it's a bit of an, maybe too busy, but you should only remember that an intense focus on HPC developments, partnerships, and deployments is needed. And an intense focus, sustained investment on HPC development, having great partnerships like with AMD and HPE, but also offering engineering simulation in different deployments. So the engineering challenges that I earlier mentioned can only be addressed by this sustained, long-standing investment in making HPC improvements release by release. And that's what you can see here on the top left, where the scalability of our CFD solver has improved year over year, reaching extreme scalability for a simulation up to 200,000 CPU cores for a single job running in parallel. And that's still a supercomputing record for commercial code that has not been beaten by anybody else. On the right, you can see that also mechanical applications do now also scale up to thousands of cores. So in addition, HPC partnerships, including the one which we have with HPE and AMD, are key for us, for Ansys, to make further HPC advancements, as well as also for our customers, to help them with scaling up and scaling out. And on the right, I'm showing that customers can benefit from various HPC deployments as needed. And I will come up with examples in the following slides. So coming back to the point that continuous HPC developments are needed. And this is just one example of scalability improvements customers can benefit from. Since our release 19.0, customers can take advantage of improvements with this so-called sliding mesh capability. It may not sound relevant, but this is a really important capability in a CFD solver. Release by release, performance improvements have been made, and thanks to all kind of improvements, like what I mentioned here on the left, intersection algorithms, reducing the overhead of mesh updates, improving data exchange strategies, and so on. Thanks to all these improvements, we can achieve better scalability for applications like rotating wheels of this Formula One car, at least the public one that I'm allowed to show. But there are plenty of those applications requiring this capability, and why it is so important to have continuous HPC developments. On the software side, customers actually can use a large variety of HPC-enabled engineering software. And only a few applications, a few Ansys products are shown on this slide. We have, as you may know, a whole portfolio of engineering simulation software applications. But I'm showing here computational fluid dynamics software Fluent. I'm showing the structure mechanics suite, mechanical. We have other products as shown here on the slide too. And on the right, I'm showing that customers can then benefit from various forms or layers, so to say, of HPC. At the highest level, parallel parametric analyses through job scheduling, then domain decomposition, followed by a deeper level of parallel processing of tasks, and then further down, vector processing of graphical processing units. All important layers, different forms, and supported throughout HPC, supported throughout our entire portfolio. So if we talk about HPC deployments, we support various hardware deployment models. Customers basically have 4 HPC deployment models, of which 3 are on-premises, shown here. Typically, simulation users are on an HPC path, or a journey, I often say, starting off with running Ansys on a laptop or a desktop computer. And as you know, many of those computers already have multiple CPU cores. Once the group of users grows, they usually start using computer server with multiple nodes so that it can enable also multiple jobs, multiple simulation jobs, I must say, and also often more complicated simulations. And they are also, of course, these servers are more IT efficient. And once the Ansys customer grows, so to say, we have with more users and users that are often geographically distributed, the customer often starts centralizing and consolidating their compute resources in a data center, while the users are sitting remotely. And then there is cloud as a very important forced deployment model of HPC, where users can use our Ansys SaaS solution or a partner managed solution. Cloud is clearly emerging, and an ideal deployment model of HPC, whether that is using the public cloud or a private cloud environment, because it enables customers and our customers to improve their business agility, their IT efficiency. Basically, the ability to scale up and down computer and license capacity is a big advantage of the cloud. The benefit that users can get the right HPC resources they need, as much as they need, when they need it, and pay only for what they use in compute and license capacity. That's a clear advantage and the reason of a quickly emerging deployment model off premises and in the cloud. But as I also mentioned briefly before, partnerships are important, crucial, I would say. And on this slide, I'm showing the type of partnerships we have and also the reasons why we have those partnerships. First of all, we collaborate with HPC OEMs to ensure that our simulation software scales well on the latest HPC infrastructure. We also work with the user community so that they can provide us real-world industrial, but also scientific relevant applications. And because it's often impossible for our industrial customers to divert their HPC systems, their production systems, to test levels of extreme scalability, we are also very privileged to work with HPC centers and also cloud service providers that provide us access to large HPC resources, on-prem or off-premises, and also access to their HPC system experts. All in all, we at Ansys, we tremendously benefit from HPC resources for software performance profiling and benchmarking purposes through all these types of partnerships. And coming back to why HPC partnerships matter, I'm showing here an example of how Saudi Aramco, the supercomputer center KAUST, and Ansys had set a supercomputing milestone by scaling Ansys Fluent to what I earlier mentioned, the 200,000 CPU cores. The challenge was not a scientific one. It was a real industrial one. It was to design separations vessels used in oil and gas production facilities. And you should know that in some of those cases, oil and gas platforms produce at only half of design capacity due to poor separation. So simulation was and still is very critical to improve the efficiency. So by leveraging HPC, Saudi Aramco and KAUST sped up a very complex Ansys Fluent simulation of a separation vessel, from several weeks to an overnight run. It was an amazing achievement, in my opinion, and to the customer as well. And I think also a great example of how HPC can be improved through a partnership. In this case, with a customer and an HPC center. Then I'd like to come back to my point about testing and evaluating how software on the latest processor technologies. We noticed a potential of the third generation of EPIC series processors for Ansys applications. First of all, I can mention the high frequency. The base and boost frequencies can be up to 500 megahertz faster than EPIC 7002 series. Secondly, and Mike was alluding to that already, the high L3 cache per core, that could be really beneficial for some of our Ansys applications. And thirdly, the 8 memory channels supporting DDR4 3200 megahertz DIMMs that could really help also, particular due to the high memory bandwidth and our high memory bandwidth sensitive applications. Yeah, and some of those applications are shown here. Yeah, applications like the CFD application shown here, as well as our LS-DYNA applications. Here, I realize this is a bit of an eye chart, but I'm showing here benchmark performance and scaling results for CFD Fluent. On the left, we are comparing Fluent performance for the complete standard benchmark suite on a single node with various third generation EPYC processors relative to that with a dual socket 28 core Intel Xeon Gold processor. And as you can notice, the single node performance can be up to 64% faster for these particular EPYC processors. On the right, I'm showing Fluent multi-node scaling for our largest benchmarks. All benchmarks scale up to 8 compute nodes extremely well, and a few benchmarks show even superlinearity, where also Mike was referring to, and that is also very likely due to the high L3 ratio of cache per core. That is really having a positive effect on the scalability. And on this side, again, showing some benchmark performance and scaling results, but then for our other CFD solver, CFX, very well known in the turbo machinery industry for engine and aircraft, being used in the engine and aircraft manufacturing industry, turbo machinery applications, many different types of applications. And here we are showing really comparing again the CFX performance for some benchmarks on a single node, again versus third gen. Performance can be even better compared for this particular workload. On the right, I'm showing CFX multi-node scaling for 3 benchmarks, and again the scaling is very well. And what I'm now going to show you is actually an Ansys LS-DYNA simulation of a 3-car collision, one of the many virtual crash tests done by car companies across the globe. It's running on 2 different systems, one using a 3rd gen EPYC processor, and one using a processor from I must admit, a 2nd gen Intel Scalable processor family. And as you can see here, the EPYC-based server performs the crash simulation faster and allowing the car manufacturers to speed up their design tremendously. So as key takeaways, I hope you would recall from my presentation that that simulation is at the center of virtual prototyping, and that simulation allows our customers to grow their top line revenue and bottom line savings. As I'm showing here, HPC is really a must to enable rapid innovation, faster time to market, and reduced engineering rework. And furthermore, a sustained, long-standing investment is also needed. I hope you got that point too, that it's really needed to advance HPC performance and capability release by release. And that partners like HPE and AMD are key to help our customers succeed. And as a call to action, feel free to visit ansys.com/HPE and ansys.com/AMD for some additional resources. So hereby, I'd like to thank you for your attention.